In this episode, we will present edge-type features. GaussDB is designed mainly for transactional workload, dominated by simple queries and short transactions. But nowadays, more and more customers demand for real-time analytics. To address those customer needs, several things have been done to speed up those queries. One technique is NDP, near data processing. The purpose of the near data processing is to push down certain operations down to storage. It's computational storage. The operation can be pushed down, including the selection, projection, as well as aggregation. This will significantly reduce the network traffic. The right diagram shows the workflow. The SQL optimizer extracts the expression unit that qualifies the pushdown. In this case, selection predicate. The selection predicate and convert into LLVM bitcode and the compute node, and then push down the storage. The LLVM bitcode is compiled into the architecture-specific native code and storage node for execution. As we just talked about, the near data processing push down the operations to the storage node. In this case, it will free up the compute power and the compute node, so we can execute the parallel query on compute node. The main idea of the parallel query is to divide the whole table into multiple partitions. Multi-thread can operate on partition in parallel. Let's look at how parallel query works. The parallel query engine consists of one leader and multiple workers. Query execution starts from the leader. The leader divides the whole table into multiple partitions, and then create the parallel query execution plan. Send the execution plan to the worker, and then aggregate the result from the workers. Near data processing and parallel query can work seamlessly together. It offers three-level parallelism. The first is SQL node parallelism. Parallel query drives the SQL node parallelism. It partitions the table and uses multiple parallel query work threads to scan the partition concurrently. The second level parallelism is a parallelism across page stores. The cell layer splits the batch read into multiple sub-batches based on where the pages are located. The third level parallelism is a parallelism within page store. The page store can use multiple concurrent threads to perform the NDP operations, with each thread perform NDP operation, which could be column projection, predicate evaluation, or the aggregation on each page in the batch. Now, let's look at the simulation, how NDP queue works. For illustration purpose, we have the simple query with three tables, F1, F2, and F3, and then we have aggregate function count star and with where clause. On the left side, when NDP queue is disabled, all the raw data is transmitted from the storage to the compute nodes for execution. While on the right side, when NDP queue is enabled, our query plan is pushed down to the storage engine for parallel execution, and the result aggregated to the compute node. It will greatly reduce the network traffic. Again, show me the number. This diagram shows 22 TBCH query plus 3 specially designed queries. The blue bar shows the runtime improvement, while the yellow bar shows network traffic induction. So you can see with NDPQ enabled, we can achieve up to 90 times network I/O reduction and up to 30 times runtime speed up. GaussDB is a cloud-native database with great performance, better scalability, and availability. But we don't just stop here. Here we list the 5 trends for cloud database and 6 technologies and development. We firmly believe those new developments will bring more value to our customers. Now we have presented the unique design of Huawei cloud-native database GaussDB and several important features. Thank you for watching. Hope you enjoyed the content.